So today's lesson, topic 3, is about solving inequalities. So let's start off with something that is just linear, and then topic 4 is nonlinear inequalities. But part of topic 3 is also to put a little bit of a complication. What happens if you have linear inequality, but what happens if you have absolute value? So we'll do linear ones and then nonlinear for the second topic here. Okay, so when you're solving an inequality, we have to remember one law, one main rule that maybe if you're putting things into your survival guide or cheat sheet, you could put this main rule up here. What is the main rule with working with inequalities? I'll start it off. If you multiply or divide, oops, I can't spell divide, by a negative, what happens?
The sign flips.
The sign, whether it's this one, flips to that or vice versa. And if you have an equals, then the equals comes along with it. Okay, so let's solve this as if this was an equation. We want to subtract from 5 from both sides. We'll have negative 2x is greater than negative 1. What's my next step?
Divide by negative 2.
Okay, so next line down, continue. Whoever said that just now, it would be x what?
X is less than 1 over 2.
Yes, Raquel, less than positive 1 over 2. And then if you wanted to draw this, you would say, okay, this is where 1 is, this is when 0 is, so 1/2 is somewhere in the middle. We're not going to shade the 1/2 because it doesn't say equal to, but we will shade everything below that. Right, so yesterday we talked about how to do set notation and interval notation. So in set notation, it's going to look like set of, so you'll have these braces. You'll say set of x element of real numbers such that x is less than 1/2. So basically exactly what we had in our solution, but then just put that in the set brackets. And the interval notation, how would we record solution in interval notation? X element what?
You'd have soft bracket negative infinity.
Yeah.
And then comma half, also the soft bracket.
Yeah, the open or round bracket. Very good. Okay, so that's an example how to do linear inequality without complications. What I want to do now is work with still linear inequalities, but a bit, what if you had 2 of them? And sometimes you'll have the word and in between 2 things, or sometimes you'll have or. So remember how yesterday we talked about, I think topic 1 in the very bottom with our symbols. I mentioned that this union is the or, and this intersection is an and. So I want to tie this piece into solving linear inequalities right now, because that can occur that you have 2 of them at the same time, but then you'll have or, the word or in between or and in between. So I'm not going to do these 2 questions. I'll do these 2 over here. First of all, let's start with question 3. If you have x nested in between, so nested in between 2 values, that's implied that it's the same thing as using the word and if you were to separate it. So this is the same thing as writing down negative 2 greater than x and then saying and x less than 1. Now I prefer to record x first. So instead of saying negative 2 less than or equal to x, I prefer to put x first. So if you change the order, of course, the sign comes to the other side. So it still says the same thing, that x is the bigger one. Okay, so this is equivalent to that. So your question and concept checked will be very similar to what I just did here, right? So let's take a look. So if you had something like that, I want to show you how you can think about it. If you have 2 inequalities and you have the word and in between. So I'm going to use a highlighter to make sure that you get what I'm trying to do. So this is the blue one, and let's say a yellow one, okay? So first of all, draw a number line, of course, and make sure you put negative 2 on the left of 1 because it's obviously lower number. Put it in order. And then you're going to shade things. Okay, so -2, because it is with the equals, I'm going to shade this -2 in, but 1 doesn't have equals, so it's going to have an open circle. And then the actual shading I'm going to do with my marker. Okay, so this is saying x is greater than or equal to -2. That means it's going to go on and on and on forever this way to infinity. That's this first blue one done. Any questions about that one? Then the yellow one says it is less than 1. So it's not 1, but it's the one that's less than 1. It goes on and on and on forever to the other side. And so then, because the word says and, you see the word and? That means we need to select where both regions are shaded in. So where both are shaded in is obviously between -2 to 1, which we already knew that that's how it looks when it is this inequality. So I'm just explaining to you, if it looked as two separate ones and there was the word and in between, this is what it looks like. And if you were to convert that to interval notation, you would say x element from -2 with a square bracket to 1 round bracket or parentheses. Okay, so let's do the same type of thing, but what if we had the word or? Okay, so first of all, if you don't have the inequality already solved, this one's already solved. You see how x is isolated? So then you have a few more steps that you have to do before you actually start plotting it. So you would maybe subtract 3 from both sides here and divide by 3 here. So first inequality will be x greater than 4. And keep the word or because it's important. It changes our solution. And the other side will have x is greater than. It doesn't flip the sign because we're not dividing by a negative. 6. So here I was subtracting, not dividing. Here I'm dividing. Any questions so far? All right, draw them. 4 goes first because it's lower than 6. Don't shade 4 in, but do shade 6 in. And just like before, I'm going to use some colors just so you can see what's what. This one's going to be my blue. Everything bigger than that one goes all the way up to infinity. And then the yellow one, it is from 6 and also all the way up to infinity. What is the final result as a sketch? What do I shade?
Both lines.
So just this part where both of them are? Is that what you meant by both? What did you mean by both?
I meant like from 4 all the way to infinity.
That's right. You got it. Julian, thank you. So you do want to go from 4 to infinity because when it says or, that means anything that's shaded you capture. Okay, so when you see the word or, it's anything shaded is, shaded is part of it, part of solution. When you see the word and, think only both shaded parts are part of solution. Any questions about that? Okay, so something else that you should maybe put down into your notes. So remember how I said I always will try to give you an idea what are key things to record. So maybe you could record notes about the and, notes about the or, but also I have something else written over here. There's some words that some handouts or textbooks use. I want you to be aware of them. The word dis means apart. So at this junction, we'll have 2 separate pieces, which I don't have a picture of here, but we had in your concept check yesterday. Let's see, not this one. This one over here. This would be called a disjunction, number 19, because it's 2 separate pieces, right? And of course, anytime you have separate pieces, it's a disjunction. But if you have only one shaded piece, that's going to be called a conjunction, okay? And that's what is being told to you in this side here. So con means together, so conjunctions represent one piece. So this would be a conjunction, okay? So I'll leave these for you to try in your concept check later after the lesson is done. Let's talk about the complication. If I threw at you not only just an inequality, but what if we had absolute value? So first, let's start with equals. What happens if we have equals? Talk about what it means to be an absolute value, and then we'll add in those inequality pieces together, and then we can move on to nonlinear type. All right, so solving an absolute value equation. Absolute value is denoted by the bars, and what it does, it represents the distance the number is from 0. So I know you've probably been told just ignore the negative. Well, absolute value of 8 would be just 8, and absolute value of -3 will be +3. But you may not have heard the fact that it actually represents a distance the number is from 0, because distance is supposed to be never negative, right? Never negative. And so it makes sense for when we're talking about absolute value, we're thinking about it is a distance. Note to my AP students. My AP students in the class have already done vectors. And so the vector would be kind of AB, like this, AB. And we recorded AB with a magnitude symbol. Remember how that magnitude represented length. So magnitude, length, or distance, same thing. Okay, so just so you're aware that there's overlap to something else that all of you will be actually studying absolute value on a vector in calculus and vectors class. It's just that part of the students have already seen it in grade 10. Okay, anyways, back to this. So I'm going to demonstrate this distance with this particular question that I have added, not just the x equal absolute value equal to, I have, an actual equation here. So first things first, we are going to think, because we're trying to solve, when we solve, we follow SAM-DEB order. SAM-DEB, basically BEDMAS backwards. Think of these absolute values. These are like the brackets. They're a special type of brackets, but they're still brackets. That means we do not have any adding or subtracting outside of the bracket. So I know there's a plus here with a 2, but we can't touch that because brackets is all the way at the end. So that's out. Do you see any multiplication division that we need to get rid of?
Yeah, divide by 6 on both sides.
Okay, so let's divide by 6 on both sides. What number do we get? Does it go in evenly? I don't know.
Get 52.
Yeah, 52.
52. Okay. Then there is no exponent, there is a bracket. So for us to remove the absolute value bracket, this is where we put plus and minus, because there's actually 2 choices of what the inside could have been. The inside could have been a positive version or a negative version. So when you remove absolute value, you do that next. And then you separate this out, because there's two answers here. We could have 5x plus 2 equal to 52, or we can have negative 5x plus 2 is equal to 52. Let me give myself more space. All right, what's the next step in this first one? Brackets are done, so we're starting SAM-DEB. Say it again.
So move the 2 over.
Yeah. So 5x equals 50. So what is x?
10.
Okay. And then what about on this side? What do you want to do? Distribute the negative or divide by negative? Many choices. Just tell me.
Distribute the negative.
Sure. So negative 5x minus 2. Then add 2. Or not 2, no, I put 5 by accident. That could have been a point for someone if you were quick. 54. And then dividing by 5. What should be the answer? Negative what?
Negative 10.8.
Should we put it as a decimal or should we leave it as a fraction?
Fraction.
Yeah, because this is not something we're plotting necessarily, so leave it as a fraction so we know it has not been rounded. Okay, so this is a solution to this equation. And I never talked about the distance. This is not, I just realized this is not the best example to talk about the distance, so let me talk about distance when I do the next part, okay? Any questions before I do it? This is good. So to remove absolute value, you make it in a regular bracket, but put plus minus on the side where the absolute value was. I kind of mentioned this before to you guys when we talked about, x squared equal to 4, how you do absolute value, or sorry, square root of both sides. And this actually represents an absolute value because absolute value makes things positive. Well, if you square something and then square root, it's going to become positive just like absolute value was, right? And then for you to remove absolute value, you'll have plus minus here. Or sorry, that shouldn't be a 4. It could have been a point for someone again. Square root of 4 is a 2. And then to solve for x, it would be plus or minus 2. So in the past, you probably just went whoop, straight to this, right? Okay. But the reason behind it is because of this absolute value, just so you're aware.
Miss K.
Yes.
For the question you just did.
Yes.
That question asking to solve for x
yeah.
with an absolute value, or is like the answer?
No, just when it says solve, just means solve means to find value of x. Now, because Josh, you asked that. Can I, thank you for reminding me. I usually go over the different, I just want to go to my grade 10 because I just did it with them. Hang on. Just the differences between the words. I'm just going to copy it in here. And I'll put it. Over here. So you want to be very knowledgeable of these words and what do they mean. Solving versus factoring versus simplifying versus evaluating. So the question in R, it says solve, right? So what does it mean to solve? Solving is to find its solutions. What are the values that fulfill the conditions stated by equation? So you have to have an equal sign, which we do. Right, because we have an equals, so that's an equation, and solving means to actually find those values. Now, inequalities would still be solving an inequality, but we don't call it an equation, we call it an inequality, but it's kind of, it falls into this category as well. When you use the word simplify, it's just meaning, try to make things shorter, collect like terms, distribute brackets, things like that, right? So just so you're aware, I place this for you. Make sure you use right words. And know what they mean. So is it okay to move on to putting inequalities with absolute values, not just an equation?
My question was.
I didn't answer your question. Go ahead, try again.
My question was more so, like the wording of absolute value. Like, are we solving for x, but the normal value of x, if that's okay.
So if you were to put this 10 back into the equation, it will make it true. Okay, let me prove it to you. So let's do a check.
I'm just wondering where it will always be positive will come into play.
You'll actually get 2 answers, just like we did here. So you're supposed to get correct answer this way. So you could say this is 50 plus 2, that's 52 times 6, that would be that one. Or the other one that we got, 5 times negative 54 over 5 plus 2 absolute value should be also 312. Well, if you multiply these together, you would get just negative 54 because 5s will cancel, right? Then when you add negative 4 with 2, that would be negative 52. The absolute value on the negative will make it disappear, so it'll become positive, times 6 will give you the same answer.
Yeah, okay.
All right, so what we're doing here, we're able to find all the solutions possible for that equation. Usually you get 2 solutions with quadratics, right? So if I had a quadratic, something like this, equal to 0, then you're also going to get 2 solutions there too. because we have x minus 4, x plus 1, I think I made that correct. And then you have two solutions here too.
So
so-
pretty much it's fine if our answer is negative because the absolute value brackets will just make it
Yes.
positive.
Yes.
Right.
Yeah. So there's certain types of equations that will yield two solutions. Some of them will be three solutions, like cubics. We will study next unit how to solve cubics, quartics, and so on, all types of polynomials. Okay, so can I move on now, or is there anything else?
No, that's it.
Okay. All right, so what we're going to do now is throw in on top of absolute value also not just equal to. So maybe before I do this question, let me just do baby steps. What if I had x absolute value and then just equal to 3 before I do less than, okay? So this particular one, what does that represent? And I want to talk about, what I said here about the distance part, because it would make sense when it's a simple version like that before we get to complicated. So what I'd like you to think of, if you were to actually proceed and solve it like I just showed you, you remove the absolute values and place plus minus sign on that side. And so that means we'll have x equals 3 or x equals negative 3. So then you proceed to put that onto your number line, negative 3 and 3, put a dot here and a dot here. You're not going to shade anything in between because it's not an inequality, it's just equals. And the 0 is in the middle, right? So in terms of distances, because it says absolute value represents the distance a number is from 0, right? So you're basically asking yourself, what is the number whose distance from 0 is 3? Well, 3 is a distance of 3 from 0, but also negative 3 is a distance of 3 from 0. Do you see what I mean? So it's like as if there's a distance here of 3, it's like a radius, and distance of 3 here to the other side. So that means you incorporate both negative and positive possibilities. Okay? So if you're okay with the equals, so if it's equals, you just get 2 dots. So this question right here also would be just 2 random dots. But if you have an inequality, then you possibly will be shading on the inside or possibly on the outside. So let's talk about which ones when. So this particular one, it says we want the distance of all the numbers to be less than or equal to 3. So if I were to draw, here's my 0, distance from 0, let me be specific, from 0. We want numbers to be all the numbers shaded so that the distance to 0 is at 3 or lower. So obviously 3 itself is going to be shaded. And numbers below 3 will be the distance lower than or equal to 0. But also on the other side, wherever negative 3 is, well, negative 3, its distance from 0 is still 3. And let's say negative 2 over here is also distance below 3. So I should be shading all of these down. So if you see absolute value of and then less than or equal to 3, you could think about it in distances. Some people don't like that. So let's just do it algebraically. So I'm just going to show you different ways of thinking about it that make you arrive to the same conclusion. So you could do it with distances, or you could say, well, I'm just going to solve it in the usual way. Imagine I never even drew this. You're going to say, I'm going to remove absolute value and place plus minus on the same side that the absolute value occurred. Then you're going to split off this into 2 separate pieces. So you'll have x less than or equal to 3, or negative x is less than or equal to 3. Now I need to decide which word I need to place here. Would it be an and or an or? You cannot just put a comma and assume it's going to be okay, because as you saw, an and an or completely change what you're supposed to be shading in. So that's why I started by talking about distances, so you can actually see that it is a conjunction, that it's going to be shaded on the inside. So because it was less than, there's some things I wrote down for you to put over here. Do you see over here? There's little notes. Actually, I'll read that after I do the question so that it is more understandable. It's basically a way for you to remember which one's which. So this is the one that's and. It has to be an and because it's a less than, and the distance is going to be lower than a particular number, so it's going to be shaded on the inside. It's going to be looking like that it's nested between two amounts. Between. And then this symbol is less than symbol. Less than. But instead of me writing less than like usual, I'm going to write down less than using an and. So you remember that it goes together with the and when you're separating it out. Cannot be an or, cannot be just a comma, cannot be a nothing. You have to put in a word when you're separating it out like this, okay? What else did I want to say? Okay, I'm not done, so let's continue. For me to solve this one, do you see how there's still that negative on the x? Let me just move it over so it's clearer. I still need to isolate for x here. So it would be x is -3. What happens to this sign over here, guys?
It flips to the, sorry, greater than symbol.
That's right, it has to flip to the greater than symbol. So I still have the word and in between, and then x less than or equal to 3. And so now this question became just like the previous questions we've talked about. This is going to be saying I'm shading from 3 and on this way. And the other one is shaded from -3 and on this way. And because of the word and, that means we want to see where they are both shaded in. And that's exactly what I already had originally when I talked about the distances. Okay. Now you have to be very careful about this less than. Recall how I up here. You know how originally I had this written? I had this written as -2, and then I had less than or equal to x, and then I swapped so that x is first variable. First, that's a good thing to do all the time, because this thing that I told you just now about the less than, you know how I wrote this down? If you wrote this up as 3, which is still a true statement, greater than or equal to this absolute value, then this symbol looks like it's greater than. And then this whole thing of a trick to how to remember it is out the door. So always try to put the variable first and then look at, okay, what's the symbol do I have? If it's less than, then think it's going to be an and in between when you're shading it. Or if that's too much work, just think about distances and go from there. Because if you think about distances, you're done. And the solution, you would say, therefore, the solution is x element from -3 to 3 is a solution to this inequality. Let's do another one. I have a few here because this is brand new. So at first it's probably going to be a little bit hazy. Oh, and another thing, I said one way to remember this, less than, but I also have this word nested because your shading is nested in between something. So on the bottom, I wrote down 2 things you can think about. You could say less is nest, because less than, and you're nesting in between, so you're shading in between. Okay, so I'm going to show you this other one now. So what if you have a different symbol facing it a different way? So again, I'll do it in 2 ways. I'll talk about it in distances, which is fast, but some people find it confusing. And then I'll just do it with algebra step by step, how everything fits together. Okay, ready? So let's do it with distances like before. We're going to think, what are the numbers that have distance from 0 greater than 5? So plot your 0 and think, we want to only start shading numbers that have distance greater than 5. So I can't even shade 5, but I would have to shade onwards all the way there, but also from -5 onwards that way forever. So that's going to be an open circle here, open circle here. So that's done. So if you understand distances, then this is really, really simple to use. But I'll do it with algebra as well so that you can see how everything fits together. So let's do it with algebra like I did with green. So what you're going to do as before, you're going to change the absolute value to become not there, put plus or minus instead, and then separate into 2 pieces, either positive greater than 5 And on the other side, I'm going to have negative x greater than 5. And now we have to decide what word do I stick inside here. Is it an and or an or? Do not leave it empty because it actually makes a difference. So if it was x greater than 5 and x negative x greater than 5, we have to use the word or. Otherwise, it's not going to match this picture that we did here. So because you have the variable first and you see a greater than symbol, the way to remember it is to think gray. Instead of writing greater, I'll just put or capitalized here, great or, right? So the word or another saying, because greater than is like more, you could say more is or. I don't know if that helps. And this one was less is nest. Okay, so let's continue on. We didn't finish this. This is isolated. X is isolated, but this side is not. So I need to divide everything by -1, just like we did before. And it flips our sign and we get -5. And just like before, if I were to use the highlighter to point out what's what, this particular one says x is greater than 5. Well, that's this one. And then this one says x less than -5. It's that one. And that matches exactly what we had before. So your final solution would be not just the shading. You would say, therefore, x is element of from -infinity. Never put a square brackets on infinity because we can't ever reach it. So just round one up to -5, round bracket here. And then you're going to use the u, because u is the same thing as or. So it's a union, 5 to infinity. Now, before I proceed to do more examples, I want to prove to you that if I had same questions, actually, let me just do it below. Just to prove to you that it is very important which word it is if I were to swap it. Imagine I had the same question as this, same solutions, but I changed the wording. And how would that affect my picture? Here's -3, here's 3. Look at the shading up here, the blue and the yellow. And remember, or we said you shade, anything shaded is a solution. Anything shaded is a solution. So what should I be shading here?
You would shade everything?
You would actually end up shading everything because it above here, yellow is shaded somewhere or blue is shaded somewhere or sometimes both. So if that was your thing, then your solution here would have been X element of reals. You see how vastly different this is? This solution versus that solution. And you can see that just a little word like that changes it completely. So it is important. Let's do this one, the same thing. Let's do X greater than 5. And let me change from or to an and. Imagine we had an and in between instead. And look over here, the word and, we said both have to be shaded to be a solution. So what do I shade on this one here then? Look above. Is there a place where both of them are shaded at the same time?
No.
No, so the solution here would be an empty set. There's nothing there. So that kind of actually looks like it's a 0 there. So you should maybe say that it's just empty bracket, there's no solution, or just say no solution as the words. Okay, so do we understand the fact that these words are super important? So if you are going to do it by algebra, not using distances, then you need to specifically write down what the word is between these when you split it up, and then make sure that you create a final statement. What is the true solution to this inequality? Okay, so we drew on the number line, it said it, and convert to interval notation. So both of those are done. Let's do a few more.
Miss K,
Yes.
why would there be no solution for that one?
Why would there be no solution for that last one? Can someone help out? Why is this
Because
no solution?
because when you have an and, both of the statements have to be true in order for it to or in order for it to be shaded in.
Mm-hmm. So can you
So
think
if
of
it-
a number that's both bigger than 5, but also at the same time less than -5? Because you're saying the word and, that means it has to be both bigger than 5 and at the same time less than -5. Can that be true? It can't be, correct? There's no such number.
Okay.
Yeah. So just remember, that's why I said when you're putting things into your notes to highlight, like what I've highlighted in green, put in or. What does it mean to have or? And what does it mean to have and? Just because because it's new, you might forget which one's which, okay? All right. So this one right here, let's do it. Let's skip the full algebra steps. Let's go through distances right away because it's pretty easy and doesn't involve a lot of steps here. So distances. Distance from 0 of all the numbers we're looking for have to be less than -2. What do I shade? Hint.
Shade
Distance, can it be negative?
No.
No, so you're saying distance is supposed to be lower than a negative number, so it itself should be negative. So there would be no solutions here. No solution since distance can't be negative. Done. If you wanted to do it with algebra, you would do the same thing. Let me just do it very quickly. So I'm not going to explain step by step anymore. I'll just write and you follow along and tell me what to explain if you got lost, okay? Split x less than -2. I see the word less than symbol, so I know it's supposed to be an and because it's less than. I don't know if that helps you. And so then on this side is -x. Divide x, flip the sign, +2. And so we need to have -2 and 2. We have to be below this one and at the same time higher than that one at the same time. Can't have both. Can't do both. Shaded. And so the solution is no solution. Do you see how it gets repetitive after you see a few of them? What about the next one? What if I said distance from 0 has to be greater than or equal to -2? Greater or equal to -2. What do I shade? What are the numbers whose distance will always be greater than -2? Remember how distance is positive?
-2 to +2.
No, more than that.
All the numbers.
All the numbers. Okay, so if you don't believe me, if that was, too hard to comprehend, do it with algebra. Same idea as before. You'd say, okay, plus or minus, drop the absolute value, keep everything else the same, split it up. What would be the word I would put in between? What should be the word over here?
Or.
An or, because this is a greater symbol, greater, or more is or, whatever you prefer. So you have to put the word or, divide by negative on this side, flip the sign. And so when you're plotting this, we're looking for -2 and greater than that, or +2 and less than that. And because it says or, that means everything gets shaded, just like we set up here. Questions about this? Okay, so let's up the ante. So look, I tried to build on it from easier to harder. So we talked about what happens if we have equals. Now we talked about if it's less than or greater than. I showed you what happens if we have a negative on that side. So usually absolute value is supposed to be a positive on the other side, but if it has a negative on the other side, then it's either no solutions or everything is a solution. Most of the time you will not get a negative on the other side. This is just like a trick type of question, but I want you to be aware how to deal with that, so I talked about it. But what if we have not just x by itself? What if there's more things to it? So this is the last of this type before we do a nonlinear type. So your first step is to isolate for the absolute value portion. Because if you wanted to use distances version, you need to have the absolute value isolated if you wanted to use distance method. But I'll show you the algebraic method as well for distance method. What you want to do is have, I guess I have it written over here. Have it written over here. You want to have x without a coefficient, and you don't want any coefficient on this side, okay? And I'm going to just show you what this represents here, okay, with an example. So for distance method, need absolute value isolated. And you also want no coefficient on x. So if there is one, we'll fix it up. So notice how this one has a -3 in front. This one has a 2 on the inside. I'm going to show you both ways, but I'll also show you the algebraic version because some of you most likely will prefer that instead. So let's do it. I'm going to get rid of -2 or -3. What would be on the other side of x plus 2? I need to get rid of multiplication by -3.
It would be greater than or equal to 8.
Yes, so notice the sign flipped because we're dividing by a negative. Very good. And at this point in time, if you were to use distance method, here's what you're thinking. You don't have to proceed with anything else. You can go right to sketching it. You're thinking of this 2 as actually a subtraction. Kind of like when we did quadratics, you thought of this going to the left. There's a swap of the sign. So your center, this is your center. So the -2 is your center. And this is your radius. It's positive, so that's good. And as I said, you usually will have positive on this side. So when you're drawing this, you're going to put the -2 as your center. And you're going to go up 8, down 8 as your radius, and locate each of these points. Could someone tell me what these points would be?
-10 and 6.
Mm-hmm. Okay, now we just need to decide what to shade. Do we shade on the inside? Is it a conjunction, nested parts, or is it going to be a disjunction that we're shading on the outer edges? How do we decide? We look at this symbol. This symbol is greater than. So greater. What was the other saying I told you? Greater or more is or. Doesn't really, it's a disjunction. I don't know how to give you another one. So it's going to be on the outside and including the 6 itself because it says equals. Same thing on here, equal to -10 and down below. Okay, so that one's done with a distance method. So just thinking about where is the center and how far away are you from center. So we're basically saying, instead of distance from 0, this would be like, what is the distance? What are some numbers that have distance of 8 from -2? That's what this is in terms of distances. You're asking yourself, what are the numbers that have distance not of 8, is greater than or equal to 8. So I should probably put that in. So distance greater or equal to 8 from -2. And so those are the numbers that I've shaded that satisfy this sentence. If that was confusing for you, that's okay. Do it with algebra. Let's switch the color so we can do algebra in green. Give myself more room, I think. So at the point where I have x plus 2 greater than or equal to 8, split it up after you remove the absolute values. So remove absolute value, make it like a regular bracket, and then split it up. Either positive version or negative version? What would be the word in the middle?
Or?
Or. Because this is greater or more is or. Okay, so then you solve each one of these inequalities. So -2 from both sides. So you'll have x is greater than +6. That's exactly what we already shaded. Do you see this? And the word or means it's either one of those going to be shaded. On this side, I'm going to divide by negative first instead of distributing. I prefer that. That means I just need to flip that sign to be -8, then -2 from both sides, and I would get x is less than or equal to -10, which is exactly what I have over here. And the or does make it so. So your final solution, because you have to do it in interval notation, you would say x element of -infinity to -10, closed bracket union, because union is an or, from 6 onto infinity. Any questions?
Yeah, how do we know it's -2 in the absolute?
How do we know it's -2 in the absolute value? Over here for the center, are you talking about?
Yeah.
Yeah, so that's a rule that you would record for yourself. Do you see how I have it in green? If you wanted to use the distance method, you have to get it into this format that you have radius on that side, and this radius has to be positive, otherwise it just breaks down. As you saw, when you had negative on the other side, it just either means no solutions or all the solutions, right? So you have to get it into that form for you to be able to know what is the center, and it's always x minus the center. So if you see a plus, it's going to be negative. If you see a minus, it's going to be positive center.
Okay, thank you.
You're welcome. Let's do one more. So again, I'll do it in 2 methods. You get to choose what you want to put down into your examples and how you do your questions. I don't really care how you do it as long as you do it correctly. So for me to use the distance method, I don't want to have this 2 here. So what I'm going to do is I'll pull out 2 first, like so. Any questions about that first? Okay, next part. Because this 2 is positive and we have a multiple, it is all right to do this. Pull the 2 outside of the bracket, and that's totally fine. And even if it was negative, let me just show you. Let's see if we had x plus 4 absolute value. Basically, we can do -3 absolute value and x plus 4 absolute value by itself, so it becomes like this. So when you pull out a factor outside of the absolute value, it just becomes a positive. Right? Just please, please, please don't do this. So if you had 2 values, 5, let's say -7 in absolute values, please don't separate it out over binomials and say it's the same thing. That's not the same thing. That's not allowed. But if it was multiplication, 5 multiplied by -7 in absolute value, it is okay to do absolute value of 1 and absolute values of the other. That will work. This will not work. Okay? Questions about the side note? So if it's a multiplication, you could just pull it out, make it a positive. So 2 is still a positive inside or outside. So the reason why I wanted to do that is because I want to see what is my x and what is my center. And I don't want this 2 here either because I want the radius to be by itself. So the next step is to get rid of that 2 by dividing, like so. So this is my center. Specifically positive, so if you see a negative, it's actually positive, and this is my radius. So the sentence here, if you're thinking about distances, we're looking for all the numbers that we're going to shade, which are distance greater than 5 from not 0, but from the center 5/2 or 2.5. So let's draw. 2.5 is my 5/2 fraction. I want to be a distance of 5 from this. So +5 here, -5 here. Can someone tell me what these numbers would be first before I start shading? You can give me decimals if you wish.
-2.5 and 7.5.
-2.5 and +7.5. What would that be as fractions? -5/2, and what is 7.5 as a fraction? Something over 2.
15/2.
15, yeah. So it's better to actually leave it as fractions. Anyways, I didn't shade anything yet. So we said we want all numbers that are bigger than distance of 5 from the center. So are we shading on the inside closer to 2.5 or farther away from 2.5, the center? We want the distances to be bigger than this 5. Where do I shade?
Outside.
Outside. And I'm not going to shade the actual endpoints because it doesn't say equal to, right? It just says greater than. So that one's done. Let's just do it with algebra. If you really don't understand that, then feel free to use the algebraic method. It just takes a little bit of time. So let's say I'm going to continue on from this step over here. Or I could actually, let me do it from the very beginning. Doesn't really matter. So you're going to do plus or minus, drop the absolute values, keep everything else the same. Zoom in on it, separate it out. What word would I be putting in between? So think about that as I write. What word goes in between? And or an or?
Or
Or
Or. It's greater again, right? So or, continue solving plus 5 on both sides here. So 2x greater than 15. X is greater than 15 over 2. I think I already have that shaded. Do you see that? That matches. Yeah. And then or, same idea. We can divide by -1 first, flip the sign. Add 5 to both sides. -5. So x is less than -5 over 2, which is exactly what I have shaded up there. So your final statement, you should always do in interval notation. So you'll say x is element of -infinity. Look at your shading because that's the one that you want to use. And don't use a decimal here because if you use a decimal, we can't tell if it was rounded. Use the fraction version. Round bracket because we're not including u, or put the word or. 15 over 2 to infinity. So that's topic 3. Anything?